Alright, this is the Unit 8 practice test part 2. If you remember, we broke this test up into two halves. This is the practice test starting with the second half. So we're starting with question number 16. And it says log x equals -2. The directions say solve. So remember what we said here, guys. If you see a log and there's no base here written, we can assume there's a 10. Here we're just going to convert to the exponential. And we're going to say x equals 10 to the -2. We got a negative power, so that simply equals 1 over 10 squared, and x equals 1 over 100. Number 17 says log 64 x to the -3 halves. Okay, same thing, walk it over, and we're looking at x equals 64 to the -3 halves. I'll go ahead and deal with the negative power first, so that's going to give me 1 over 64. Alright, converting from a rational exponent into a radical there. And we're looking at x equals, let's see, this is an 8. 8 to the 3rd is, I believe, 512. So the answer is 1 over 512. Number 18. Now, when we're looking at this one here, we're going to go ahead and say, or we're going to have to use our property of equality for logarithms. Okay. So let's be careful here and make sure we don't just start doing random stuff. Remember, there's no such thing as you can just logs disappear from equations. That's not a rule. That's not something we do. Okay. So the property of equality tells me if I have a single log equal to the same single log, these values simply equal each other. So I don't have that here because I got 2 logs. So I'm going to go ahead and use the quotient rule here, quotient property, sorry. So this gives me x plus 3 all over x equals log base 7, 2. So now that I have the single log, these have to be equal to each other. And a lot of people get confused on this particular question here. And what I'm going to go ahead and do here is realize it's also a fraction. I'm going to cross multiply. Kind of coming over here, so we're in a room and say 2x equals x plus 3. I'll subtract x to both sides, and x equals positive 3. Now remember, guys, you could have what they call extraneous solutions, or something that's not going to give us something that's that's not possible. Meaning, remember, this value and this value cannot be negatives. So I have a positive 3. If I plug it in here, I'm good. Everything comes out positive. Okay. We'll go ahead and switch to a pen. You might be able to see a little bit better here. Number 19. Says log base 2 3 plus log base 2 x minus 1. Okay. So remember, I'm going to use that property of equality, so I got to get down to a single log on each side. So here I can use the product property for logs. Okay, and that means I get to multiply this one times this one using my distributive property. Now, sorry, this is a 2, not a 3. Okay. Now I look at these and I go, okay, I'm going to go ahead and put those two together. Because I had 2 identical logs. I'll go ahead and solve here. Add 3 to both sides. Divide by 3. And x equals 2. Once again, checking for extraneous solutions or things that don't fit here. If I plug in a 2 right there, I will get a positive number, so I am okay. Number 20. Now this is a big transition here in the types of questions. A lot of people make mistakes here on these next couple. And it says log base 2 4 plus log base 2x equals 6. Now look at this, there is not a log on both sides, so what that means is I can't use my property of equality for logarithms. I'm simply going to reduce and then convert to the exponential. So I'm looking, basically what that means is this. Here is a plus, I'm going to use my product property. Okay. Now I'm going to convert to an exponential here, right? And this gives us 4x equals 2 to the 6th. 2 to the 6th is 64. Divide by 4, and x equals 16. Okay. Look at the next one, number 21. Same type of problem. Okay. And we're looking at log x plus log x minus 3 equals 1. And once again here I don't have a log on both sides, so I can't just set the logs equal to each other. So I'm going to go ahead and use my product property, which tells me, once again, using distributive property here. A lot of people get stuck here. Well, remember guys, there's a 10 right there. We assume there's a 10, there's no value written, and we convert to the exponential, and we're looking at, and guys, by this point we should easily recognize this as a quadratic. I'll go ahead and set it equal to 0. Oops, sorry, that's a minus. Then I'm looking for something that multiplies to negative 10 and adds to negative 3. We're looking at what, 2 and 5. The bigger one has to be negative. So I set these equal to zeros, and I'm going to get x equals negative 2 and x equals positive 5. Now go back and plug in, and you see here if I plug in a negative 2, I'm going to get a negative right here, so that's going to be out. So my answer is simply x equals positive 5. For number 22, the directions changed a little bit, and they say simply expresses a single logarithm. Okay, so they're going to start something here with our natural log. Okay, don't let this wig you out. Remember, that's just log base e. All the rules remain the same. So I'll go ahead and use the product property right here. That gives me 12 minus ln of 2. Now this is a minus, so I'll use the quotient property. Just kind of show this step, right? And so let's put some equal signs in here, and then we get the ln of 6. 23. A lot of people do tend to miss this one. This is 2 log p plus 1/3 log r. Okay. So when converting to a single logarithm, first thing I want to do typically is deal with any kind of a power rule. You can see that here because I have these. I'm multiplying out front here, right? So we're looking at right, power rule. You can think of it as power rule in reverse, I guess. Okay. Then I have the product property right here, and then these two are going to be products of each other. Okay. And there's our answer. I can't do anything else with it besides that.